Picture a worldwide flood. We need to build a ship to rescue every animal species on the planet, something like Noah's Ark. How enormous would that vessel actually need to be? Would the one described in the Bible even be up to the task? And is it really enough to bring just 2 of every animal? According to the book of Genesis, chapter 6, verse 15, Noah's Ark was 135 meters long, 23 meters wide, and 14 meters high. Verse 14 also specifies that it had to be built from cypress wood. In recent times, a handful of full-scale replicas have been constructed. 3 of them come closest to what the Bible describes. One stands in the Netherlands, 135 meters long, 30 meters wide, and 23 meters high. It opened in 2012, cost 4 million euros to build, and you can visit it for 13 euros a ticket. 2 others are located in Hong Kong and in Kentucky in the United States, both offering more attractions and charging accordingly. But here's the thing. All of these replicas were designed to sit still, not to actually sail anywhere.
So if we built a copy of Noah's Ark and tried to take it out to sea, would it stay afloat? Has anyone ever even built a wooden ship that large? The answer is no, but someone came close. The biggest wooden ship ever built was the Wyoming, launched in 1909. It measured 100 meters long and 15 meters wide, which is roughly 2/3 the size of Noah's Ark. And even that ship had serious problems. In rough water, the long wooden planks would flex and warp, letting water pour into the hull. The Wyoming needed pumps running constantly just to stay afloat. In 1924, caught in heavy swells, it went down and took its entire crew with it. So building something even bigger out of wood, during a great flood no less, would be a genuinely terrible idea. That said, let's suppose the flood isn't a violent storm, but a calm and steady rain. Could Noah's Ark at least float? Researchers at the University of Leicester actually looked into this. They assumed the Ark was 144 meters long, 24 meters wide, and 14.5 meters high, with cypress wood panels 20 centimeters thick. That works out to 2,369 cubic meters of wood in total. Since cypress has a density of 510 kilograms per cubic meter, the ship itself would weigh 1,200 tons. Does it float? Yes. Taking into account the density of seawater, an empty Ark would only sink 0.34 meters of its 14.46 meter height. But of course, it wouldn't be empty. Once you start loading animals, the maximum weight before it sinks becomes 50,540 tons. So would all the animals fit within that limit? Earlier research on the subject calculated the average mass of every animal that would need to be on board. And it turns out that average is roughly equal to the weight of a sheep, about 23.5 kilograms. At that average, the Ark could hold a maximum of 2.15 million animals before going under. We quote, currently identified and classified around 1.2 million species. 2 of each would be 2.4 million. Already more than the ship can handle. But wait. Of those 1.2 million species, we need to subtract plants, fungi, protozoa, and other non-animals. Strip those out, and you're left with 9,500 animal species. Then, about 25% of those live in water, so a global flood wouldn't really affect them. That brings us down to 712,500 species. 2 of each gives us 1.425 million animals, well within the weight limit. But mass alone isn't the whole story. Animals need space to live. Assuming 1 cubic meter per animal, and given that the Ark's total interior volume is 50,391 cubic meters, the ship could physically hold that same number of animals. So far, so good. Now here's where things get genuinely difficult. Taking 1 male and 1 female of each species wouldn't actually be enough. In biology, there's a concept called the minimum viable population.
the smallest number of individuals a species needs to avoid extinction. Fall below that number, and the population collapses. Recent studies put that minimum at 1,000 animals per species to prevent inbreeding. Multiply that by 712,500 species, and you need 712.5 million animals in total.
At this point, it helps to separate vertebrates from invertebrates. There are only 28,500 vertebrate species. The remaining 96% are invertebrates. Because invertebrates are generally tiny, you could pack all of them into a relatively small space. Assuming the size of an average ant, housing every invertebrate species would require about 18 cubic meters. That's manageable, but vertebrates are the real problem. At the minimum viable population of 1,000 per species, the space needed to house all vertebrates comes out to 28.5 million cubic meters versus the 50,000 cubic meters inside Noah's Ark. The final tally? You would need 570 ships the size of Noah's Ark just to give vertebrate animals a fighting chance at survival. And none of that accounts for food storage. To put 28.5 million cubic meters into perspective, it would be equivalent to taking the volume of the heaviest building in the world and multiplying it by 11. That building, for reference, is so massive that if every person living in Spain stepped onto a scale at the same time, that single structure would still outweigh all of them combined.